Welcome to this lecture on SQL JSON operators and manipulating native JSON within SQL databases. So this lesson is going to parallel your assignment exercises with exercises that are similar to use as models for you to base your solutions on. And so let's take a look at our parallel problem number one. And parallel problem number one says, using the heroes database and the JSON unquote extract operator, that's the dash greater than operator, list the ID and unquoted JSON name column from the heroes information table. Alias the column containing the expression used to generate the unquoted JSON specifies value as name. Okay, so let's take a look at what we're going to be doing here. We're going to be doing a select. Let's start with just a simple normal select star from heroes information. I'm already using the heroes database, so that should give us all of the fields. Oops, what did I type wrong? Heroes information. Oh, that's not a comment. So it was trying to interpret that as that instruction as an actual command. Okay, so there we go. And we see that we have our key, the ID field, which is a normal SQL field, but then we have a JSON doc type field that has, in this case, one document per field. That makes it very easy for us to parse and deal with. Oftentimes you could have an entire record set in a single JSON document field. Depends on what your business requirements is or are and what you're doing with them. But let's go ahead and explore this on a basis of one document per SQL row. And again, what we need to do here is we need to use the unquote extract operator. So unquote extract is like using the unquote function in combination with the extract function. I call it the unquote extract operator dash greater than. And we're going to pull, if we take a look at our JSON records in here, looks like there's a field in each record called race and one called name and one called gender. We want to pull out the name. So the way we do that is let's first select our ID. That's just a normal select that we're accustomed to doing. And then on the JSON doc is the name of the field. Let's use our extract unquote operator. And we want to look into that string, that field, and get the delimiter called name. And that needs to be quoted. And then we're going to give it an alias. We're going to call it name. So come put that out with a column header called name from the heroes database. It's really pretty simple once you understand what we're doing and breaking it down. And now we get the unquoted values of the name field as stored in each JSON document, assuming that there is a record present, or that field is present. You don't always have consistency and well-formedness in JSON data. And that's something you need to be mindful of. And there are some operators we can use to test the different JSON paths to see if there is a path that provides a result, or if a field is missing or a value is missing from a JSON document. Okay, so it's a little different than working with the fixed schema and constraint rules like not null and whatnot in native SQL. And we're kind of dealing with a database within a database, because we use all of our SQL operations and then we manipulate the individual JSON doc field or fields in order to parse it and manage it. So that said, we've really got some very clever implementations so that we can do things like even indexing the JSON records so that we can get better performance. We'll take a look at that before we're done. Okay, so there's our first problem solution. Let's take a look at our second problem statement and how we're going to solve that. So I'm just going to paste in here the second problem. And the second problem says using the heroes database and the unquote extract and extract operator. So we just use the unquote extract, which both unquotes the attribute and extracts it. The extract operator does not remove the quotation marks. And depending on what you're doing with that data, sometimes you want to remove it and have just the raw value. And sometimes you want to leave it with the tick marks denoting that it's a string literal. Depends on what further processing you have in mind. List the unquoted JSON publisher. So we're going to unquote and extract the publisher, and we're aliasing it as pub. And the count of the JSON publisher, and we're going to group it by the publisher. Since we're using an aggregate function, you kind of expected that the grouping was coming along. So our general format, when we see something like a group by and an aggregate function, is we're going to see a select of some stuff from some table, and then a group by some criteria. Okay, so kind of have that template in mind for solving our problem, and that can help be a guide. Okay, so in this case, we want to operate first on the JSON doc field, and remember, that's not some special function. That's just literally what I named that column, JSON doc. Okay, so we're going to grab the contents of the JSON doc column, and on that, we're going to use the extract unquote operator, unquote extract, I should say, and then it's going to parse that string to find the publisher attribute identifier, and we're going to alias that, give it the column header pub, and we're also going to grab the count of something. There's our aggregate function, and what we're going to count is the JSON doc, and in this case I'm not going to bother to unquote it, there's no need, just counting it, and we want the extract from that string publisher. Okay, and our table is heroes information, and we're going to group it by pub. And we could come up here and use that whole same expression again, but why pay for it twice? Because at this point, the parser has to already have resolved it, so we can refer to it by its short name. Okay, that's sometimes confusing in queries. When can I refer to the element by the alias, and when has the alias not yet been resolved when I'm within the same query? Try it. If it doesn't work, then you can go and fully qualify it. Okay, so let's give that a try and see if this does what we intend. There we go. Okay, so I have the publisher name and then the count of that publisher. And I want to bring to your attention one interesting thing that has to do with how we do a count. Okay, so when we're doing a count, there actually is a publisher that has no value. So it's a null, it's missing from the record. So the count of it is 0, but that's however many there are like that. So there could be a couple of them like that. It's still going to report as 0 because it is a null. So You may have noticed before, sometimes in queries you use count star, and sometimes you use uh, count and of a field attribute. And the difference there is how it handles when it gets to nulls. So if you're trying to do a total of the counts or something else, you need to keep that in mind, because how do you want to handle it? Do you want to count nulls as 0 so they don't contribute to things like the averages and whatnot? Or do you want to count the number of empty records? As a matter of fact, one of the things you might do is filter to just identify, hey, how many of these records do I have, or which records do I have that are missing the publisher? And we're going to look at that a little further in an upcoming exercise. All right, so there's our solution for number 2, bearing in mind that whole null 0 count thingy. All right. So our next exercise gives us a query to run. So we just plug that in and we run that query. Okay, and so what are we doing? We're getting basically everything, every record back, as long as the race is mutant. And as we take a look at that race, mutant, yeah. So we're only getting superheroes that are also mutants. Who knew there were so many superhero mutants? Well, now we know. Okay. But what we're interested in doing here is looking at the execution plan. And one of the things we notice is that this is doing a full table scan, and table scan is not really a very efficient thing to do. We had to go through 734 rows. The overall query cost was $76.65, and this is going to get worse the bigger that table gets. The bigger the table, it's going to be linear in terms of how it adds to the performance or the query time. So every row incrementally makes things worse. That's not really ideal. So wouldn't it be cool if we could just index that? That's what we normally do, is we throw an index on that. But wait, this is not a single field. How do we deal with that when you're dealing with something that's storing JSON documents? Okay. Well, you could parse the JSON document, but then it's no longer a JSON document. You put it, create the actual fields for your database and parse it all out. That's a lot of overhead and extra processing. And I suspect if we were going to do that, we would have done that from the get-go rather than leaving it in JSON. We're probably leaving it in JSON for a very practical reason. Very often, we will be writing web-enabled applications that use a database backend as its repository. And those web-enabled applications really, really like to exchange data and process data in JSON format. It's a really efficient and well-known, widely used standard. And so we're kind of stuck. How do we squeeze the performance out of here? Well, we kind of compromise. So one of the things that we can do is we can generate something that is literally called a generated column. Okay. And so let's take a look at what kind of statement we would use to alter the table to generate that column. So I'm going to alter the heroes information table. I'm going to add a column to it, but it's not a regular SQL column exactly, because it's going to be generated. Everything here looks fine. Give it a name. We're going to use varchar 45, which I already analyzed the data and decided that that was plenty large enough for my data. But it's generated always. And what that means is every time I add a new JSON record, a new JSON document in a row, the value for that column is going to be automatically extracted and put into that column. And then if I index this column, that's where we're headed, it's going to happen automatically for me. And so I don't have to worry about continuing to run queries or process to update the database all the time. If I updated it by importing a JSON record and I have a generated column, the magic is just going to happen. So here I'm generating it always, and I'm using the unquote extract operator to populate that generace column with the unquoted value of the race. Let's take a look and see how that works. So let me just highlight this piece of code that I want to run. And then not real excited. It says, well, it was 0 rows affected, 0 records, 0 duplicates, and 0 warnings. The important thing here is that it completed. Okay, and so now if we go over and just inspect, let me refresh the tables over in the navigator. And let's look at this. The columns have been updated here under the heroes information, and we're going to find that there is now a generace column. And in fact, if we go and just say select star from, actually, here it is right here. Let's highlight that and run it. We see that we have our ID, we have our JSON document, but at the end of it, there's generace and it has that value. So you might be scratching your head going, why is it useful since you're parsing that anyway? Why don't we just parse the whole thing? Well, I don't need to have an index on all these things. And the only reason I'm parsing this is so that I can build an index to improve the query performance of the query I want to run. And by making a generated column, I don't have to worry about updating it or remembering to populate it and parse that. Otherwise, I might be writing triggers, or I'd be running a stored procedure or a query every time I imported my data. If I ever forget to do it, then some of the column values would be missing. It would be a mess. So this generated column is really kind of a handy idea. Okay, and here's where it really pays off. So now that I've got that column out there and it exists, I can build an index on it. So let me just go ahead and paste in a statement I prepared. Create index race IDX on heroes information generace. I haven't added any of the optional parameters, so I'm not making it a unique index. It's not a clustered index. There's not anything else going on with it. It's not auto incrementing. I just took the defaults, nice and simple. Okay, it's just a simple non-unique index. That's all I need. Run it. And again, I see a happy green check mark, 0 rows affected, 0 duplicates, 0 warnings. But again, if you want to prove to yourself that something happened, come over here and in the navigator window, refresh things, and now take a look at the indexes. And you see, aha, race index has happened. Now let's go back to our original query that we ran to test this thing. Let's run it again and look at our execution plan. Remember what it was before? It was a table scan of over 700 rows. Oh, look at that. So I'm doing a non-unique key lookup on 63 rows. So less than a tenth of the overhead, less than a tenth of the rows that I had to go through before. And I'm finishing up, as you would expect, much more quickly at 1605. So that's pretty darn nifty. So I can kind of have the best of both worlds, like working with native JSON and also having all the benefits of SQL and a database engine back-ending my web application. And without having to pay too terrible a price. It costs me an index and one generated column. I'm not having to parse every column out of the JSON record every time I enter it or update it, or that sort of thing. So nifty, very, very fun, very efficient, and very labor saving for me. That's a good thing. Okay, so that's number 3. And you, of course, are going to be pasting in your results there, showing the 2 queries side by side. This one, before you built the index, you can build the column, just so long as you don't build the index. This is what you're going to get, is a table scan, and very poor performance, relatively speaking. 77.65 was the query cost, and it's only going to get worse as my table gets bigger. Here I have a query cost of 1905, so 20 to almost 80, so about 25% the cost, like a 75% savings on that. That's a huge improvement. And so very worthwhile, especially as my data gets larger, or if I scale to many tens of thousands of simultaneous users or that kind of stuff, we get really wonderful performance out of that. So good. Okay, let's take a look at number 4. And our problem for number 4 says, use the JSON keys function to list the keys. So these are key value pairs in a JSON. So you would think of it as maybe the field name and the record value for that field. They're also called the key and the value in a key value pair. And so the key is the column name header, only, again, it's a JSON doc that's stored in SQL. So there isn't really a column header. That's a tabular database, mentality, like a SQL database has tables. JSON doesn't necessarily have tables, and they're not necessarily table relations, rows by columns. They might be, but that's one of the flexible things about a JSON array is it doesn't have to be exactly that kind of relationship that you're depicting. Okay, so we're going to get the keys from the JSON.column, and we're just going to do it where the ID is 1. So for just the first record, really. Okay, so where the primary key is, the ID is 1. Okay, so that sounds pretty straightforward, and in fact, it is. It's going to be a select and a from and a where clause. We know the where is going to be ID equals 1, and the select is going to be a JSON function. So this JSON function is a nifty one. JSON keys automatically strips the keys out of the document and enumerates them as a list. And let's do that on the JSON doc column. That's the only column in this particular table that has JSON values, so that's the only choice. And let's alias it. We'll call it JSON keys. And just a reminder, even though I could explicitly put the as keyword here. If I don't, it's an implicit as, so same difference. And the table is heroes information. And I think we're there. Let's run it and see. Oh, I got this up here that is not commented out properly. Okay, so now that'll run. And so here is the quoted, because I didn't extract that. I could unquote it. I could unquote this by using the unquote function. There's not a full operator that does the keys and unquote in one step. Sorry about that. Maybe the next version of MySQL will offer that up. But we get the enumerated list in JSON notation, so square brackets rather than braces or parentheses. And race, name, gender, height, weight, alignment, publisher, eye color, skin color, and hair color are the keys for the corresponding values in that particular JSON document. Okay, one thing to remember is that it's JSON. You don't necessarily have a regular schema. There may be missing elements. There may be some records that have new elements. And that's one of the NoSQL kind of big data ideas, is that you have to deal with data that is evolving so quickly. You don't always have time to guarantee or to put the data into a very regular schema structure, what we would call a process of normalization. So again, even though we're using a SQL database and our database is normalized, we can have a JSON field that deals with data that is in the JSON document format, and it may or may not be regular and normalized. So nifty and useful. Okay. Let's take a look at problem number 5. And problem number 5 is going to use the JSON search operator. And it says use the JSON search function to list one path of the JSON document stored in the JSON doc field of the record with ID equals 12 to the string JSON. Okay, so what is this whole thing about one path? We have a choice of specifying show me one path or show me all paths. And that is, again, remember that this is not necessarily a tabular schema where each field has one value. You could have multiple values or multiple appearances of it. And so we might have multiple paths. And so you might be wanting to return them all and then do further processing on that list, or you may just need one and any one will do. So kind of a different mindset than most of the stuff we do with SQL. Let's see how we actually put that into operation. Okay, so we're going to have a select. We know we're going to be using the from heroes information. That's the only table we've got on this schema. So it's got to be that one. And where, and it tells us the where clause, the ID is going to be 12. So where ID equals 12. So the only job we have here is to formulate the select function, and the select function has got to give us the JSON search. Okay, so there's a function called JSON search, and it takes as a parameter the field to be searched. So the only JSON document field that we have in this table is called JSON doc. And then there's a parameter, and it can have two values, either one or all. Am I searching for one path? Just find me the first path you encounter that resolves, or all paths that resolve to what? Resolve to what? To give me this value, Ajax. So put another way, we're asking, is there at least one instance of Ajax in the JSON document stored in row 12 or for primary key value 12? And is there? Yep, there it is. And we're asking the JSON search value that is the name attribute. So we're not pulling back the value side of the key value pair. We're pulling back essentially the key name. So we found Ajax, it is stored in the key name. Okay, and that's, now you're kind of thinking, oh, I see why, it might be worthwhile to look for all instead of one. In this case, I think we still just have one. Yeah, okay. So you can play with that and explore it. I encourage you to do so. That's number 5. We're halfway there. And assignment exercise 6, or our parallel to it, says use the JSON extract function to list the value of the name attribute of the JSON document stored in the JSON doc field of the record in the heroes information table, which has ID equals 12. Okay, so by now you can almost do this in your sleep. We're going to select something from heroes information where ID equals 12. And so now we just need to come in and tweak that. As a matter of fact, we could go ahead and run that as a test. There's the plain SQL result. It's in this JSON document that we're going to be doing our work. And what do we want to do? We want to use the JSON extract from JSON doc the portion of the string associated with that key, the name key. Bam. Okay. And there's the quoted string Ajax. And you ought to be saying, well, gee, couldn't I have done the same thing with the extract operator? And the answer is yeah, because this is the shorthand expression that uses JSON extract. So that's it. That's just showing you the longhand way of doing that. Why would you ever do it the longhand way? Can't think of why. It would be just, most of the time it's going to be easier to use the shorthand operator rather than calling the function explicitly. So, but you be the judge. If it's easier to work with it, the logic is exactly identical. Okay, so much for number 6. Number 7. And number 7 says building on your query solution for the previous exercise. So let's go ahead and bring that solution back. There's the solution we just came up with. Use the JSON type function to determine the JSON type of the field returned from the previous query. So we're going to return this field, but we want now to say, well, what type of field is it? So we just take this whole thing, that whole expression, and feed it in to the function called JSON type. And run it, and it says the type of that thing you just returned it's a string. Okay, good. Because remember, we can't just look at our table definition to determine the data type when we're talking about JSON, because JSON has, containerizes a whole record, which is composed of elements that have many different data types. So if we want to know the data type of one of them, and often we'll need to in order to dynamically build code to process it, then we're going to have to say, okay, well, what is it? Otherwise, we're going to end up with, unhandled errors and things we haven't anticipated when we get the wrong data type, because some data is malformed. So we could use it for error trapping. We could use it for dynamic processing. There's all kinds of useful things that knowing the data type of the element that's stored in the JSON document that we want to operate on. That's how we can do that and make further decisions on it. So this is not so much valuable in and of itself, but valuable for what we would then do with that information as we're building more sophisticated query logic. Baby steps. Baby steps. All right. Okay, so now we're going to exercise the JSON contains operator. So it's kind of like doing string substring processing, only JSON style. And so this says use the JSON contains function to return all records from this is iris table. It should say we're working with the heroes information table. Make a note of that. And okay, I've got that noted to fix it if I've blown it in the lecture notes. From the heroes information table, where the JSON doc field contains the, let's break this so we can read it. JSON quoted string value, quote, air-walker. And if you've become a real SQL head, one of the things that probably bugs you is to see the double quotes. Remember that double quotes are fine inside the JSON document. It's SQL that typically uses single tick marks or single quotation marks. Okay, so if that bugs you, good for you. It means you're really internalizing SQL. Now you have to regain your flexibility and say double quotes are all right when I'm dealing with strings that reside in the JSON documents. Okay, so again, this is kind of pro forma. It's going to be a select of something. In this case, it really is select star from heroes information and where. And so here we're looking for JSON contains is the JSON function we're exercising. And that takes 3 parameters. What is the JSON field that you want to work on? We only have one. So it's going to be JSON doc in this case. We're not limited to one. Remember, that's just our current circumstance, not what you might deal with in the future. And then, okay, this gets a little bit confusing. There's a single quote, and then I'm going to have some sort of value in it, and it's going to end in a single quote. So what thing am I looking for? I'm looking for a JSON quoted value. So it's going to have a double quote at the beginning and a double quote at the end. And the value I'm looking for in between is air-walker. So did I build that in a way that you could see that it's a double quoted string wrapped, which is JSON style, that's wrapped in a single quoted string that is SQL style. So double quoted is JSON style, single quoted is SQL style, and there we are. And then the next parameter we're looking for, oh yeah, it's just that the JSON expression, the JSON string that has the key key value of name. So that's kind of like the if we were going to call it a field name in JSON rather than a key value, that would be the field name. And let's run that. What did we end up with? So this whole thing returned all the fields of the SQL row that happens to have ID 11, because that's the one that contains a JSON document that has a name value of airwalker. So there's the name value, there's airwalker. That's why this one came back. And apparently this is the only one with that particular value in our JSON field. So how will we know that's true? Well, what if instead of airwalker, we change this to male, and we changed it from looking at the name field to looking at the gender field? Now you should get a whole bunch of stuff back, right? Let's see, is that true? Yeah, okay, so now there's all the male superheroes. So there you are. All right, exercise 9 allows us to further explore the idea of JSON paths. Let's see this problem statement. This says, use the JSON contains path function to complete the following query code such that the query returns the count of the records in the heroes information table for which all publisher paths do not exist in the JSON document. So remember a few exercises ago when we were doing a count of the publishers, and we found that there was a publisher that had a value of null. As a matter of fact, there were 2, but it reported a count of 0 because of the way the count function works. So that might tell you, hey, you have some irregular data. You have some data that might need repair or needs to be validated. So we're kind of doing some data cleansing. This would be one use for it. Now we can use other functions to really pick apart our data set and say, where are the problems? What problems do I have? And we're going to do that by exploring missing or present JSON contains path. So is there a path there in the record if we expect there should be? Okay, so let's do it this way. Just tell me how many. Select count star. Remember that count star works a little bit differently than if I count a specific field. Okay, interesting. From heroes information, where JSON contains path, and this takes 3 parameters. The name of the JSON field to be searched. And do you want one or do you want all? We want all of them this time. Give them all to me. And then we're looking for the JSON record, the JSON document, or the JSON string, if you like, where the publisher the count of the publisher equals 0, right? So that a little bit mind-boggling that equals 0. Think about it, or play with the previous count, and I think you'll see why that makes sense. And let's run it. And there are two records where the publisher is not quite right. It's missing there. So null, empty string, or just null also equivalence if there's no path, because again, we can't assume that we have a normalized schema. There may be parts of the record that just don't appear for some of our JSON documents. And so this is a way to suss out that irregularity and figure out whether we need to do anything about it. What you do about it is dependent on what your particular business use case is for that data. In some cases, it's perfectly fine. You don't do anything about it. Other cases, you might need to do some data cleanup or delete those records, get them into an exception table, something like that. Okay, so that's number 9. And let's take a look at our last exercise. And our last exercise says, write the equivalent query to the following using the JSON unquote function and the standard column path operator. In other words, using dash greater than instead of dash greater than greater than. So remember, dash greater than, that's the JSON extract operator, and dash greater than is the unquote extract operator. Okay, the results of your modified query should be the same as your original query provided here. Provided where? Here it is. Okay, so we can run this. It works, and it's given me, it hasn't aliased the column name, so I'm getting the expression, but it's giving me the superhero name Abe Sapien. Okay, and so what we want to do is we want to unpack this operator so that it is just going to be this operator. Okay, what would that look like? So there's the quote, so it's extracted but not unquoted, but now we want to make it equivalent. So why would we do this? I don't, in practice, we probably wouldn't. It's much easier to just use the shortcut, the shorthand expression for the extract, unquote and extract like that. But if you wanted to, it just shows that there is a discrete function, and it's JSON unquote and run it. And now we're back to the unquoted. So this whole thing does really nothing more than what the original query, which was this, did a lot more efficiently. So just to see it again, Abe Sapien unquoted, Abe Sapien unquoted, exactly the same results as far as the data returned. It's just that this one is far more compact. this one is maybe a little bit more explicit. And again, we could even replace this with JSON extract. So we could do a JSON unquote function of a JSON extract. That's really exactly what you're doing when you use this shorthand operator dash greater than greater than. That's the unquote extract operator. So learn the shorthand, learn the efficient method. It'll save you keystrokes and save you a lot of grief. All right, that's all I've got for now. Good luck on your assignment, and hope to see you in future lectures.